Good morning friends, I am Nandana BP of Industrial Engineering. Today we are going to do a problem on centrifugal pump. The question is, a centrifugal pump having outer diameter equal to 2 times the inner diameter and running at 800 rpm works against a total head of 50 meter. The velocity of flow through the impeller is constant and equal to 3 meter per second. The vanes are set back at an angle of 40 degrees at outlet. If the outer diameter of impeller is 600 mm and width at outlet is 50 mm, determine vane angle at inlet, work done by impeller on water per second, and manometric efficiency. So from the question, first we should write the given values. Here speed n is equal to 800 rpm. Head hm is equal to 50 meter. The velocity of flow. From the question, it is given that the velocity of flow through the impeller is constant and equal to 3 meter per second. The velocity of flow through the impeller is constant and equal to 3 meter per second. So, the velocity of flow at the inlet and outlet are equal, that is Vf1 is equal to Vf2 equal to 3 meter per second. Vane angle at outlet is phi equal to 40 degree. Outer diameter D2 is equal to 600 mm, which is equal to 0.6 meter. Inner diameter D1. In the question, it is given that outer diameter is equal to 2 times the inner diameter. Outer diameter is equal to 2 times the inner diameter. So, outer diameter divided by 2 is equal to the inner diameter. That is, D1 is equal to D2 by 2, which is equal to 0.3 meter. Width at outlet B2 is equal to 50 mm, which is equal to 0.05 meter. Then we should draw the velocity inlet and outlet triangle. So, in the figure, V1 and V2 are the velocity at inlet and outlet respectively. Vf1 and Vf2, Vw1 and Vw2 are the vertical and horizontal component of velocity at inlet and outlet respectively. Vr1 and Vr2 are the relative velocity of inlet and outlet respectively. U1 and U2 are the tangential velocity of impeller at inlet and outlet. Vane angle at inlet theta, that is the angle between the resultant velocity and tangential velocity of impeller theta, and the vane angle at outlet is phi, that is the angle between the resultant velocity at outlet and tangential velocity at outlet. So from the given values, first of all we can find the tangential velocity of impeller. That is U1 tangential velocity of impeller at inlet. We know the equation U1 is equal to pi d1 n by 60. So putting the values, we get pi into 0.3 into 800 by 60, which is equal to 12.56 meter per second. U2 is equal to, that is the tangential velocity at outlet, is equal to pi d2 n by 60, which is equal to pi into 0.6 into 800 by 60, which is equal to 25.12 meter per second. Discharge Q is equal to area into velocity. We already know the equation Q is equal to pi d2 b2 into Vf2. On putting the values, we know the values of everything. So putting the value pi into 0.6 into 0.05 into 3, we get the answer as 0.2826 meter per second. So we know the values of U1, U2 and Q other than the given values. Now moving on to the question. First we should find the vane angle at inlet. Vane angle at inlet theta, that is the angle between resultant velocity and tangential velocity, which can be found out from the inlet velocity triangle. So here this is the inlet velocity triangle. So here theta is equal to tan theta is equal to opposite side by adjacent side. So here opposite side is VF1 and the adjacent side is U1. So putting the values we get 3 by 12.56. Theta is equal to tan inverse 3 by 12.56. Theta is equal to 13.43 degree. So for finding main angle at inlet, we first consider the inlet velocity triangle, and in that theta is equal to tan inverse VF1 by U1, and putting the values we get the value of theta. Next question is work done by impeller on water per second. We already know the equation. Work done by impeller on water per second is equal to W by G into VW2 into U2. That is rho G Q by G into VW2 U2. Here in this equation, we know the value of rho, G, Q and U2. But we don't know the value of VW2. So first we can find the value of VW2. For finding the value of VW2, we should consider the outlet triangle. In outlet triangle, tan phi is equal to opposite side VF2 by adjacent side, that is U2 minus VW2. Tan phi is equal to VF2 by U2 minus VW2. So tan 40 degree is equal to, putting values, 3 by 25.12 minus VW2. We know the values of VF2, phi and U2. So putting the values, tan 40 degree is equal to 3 by 25.12 minus VW2. So VW2 is equal to 25.12 minus 3 by tan 40 degree. And we get the value as 21.54 meter per second. Now we know the, now coming back to the question, we know the values of rho G Q by G into VW2 into U2. So putting the values, GG cancel. So 1000 into 0.2816 into 21.54 into 25.12. So we get the value as 1,52,910.56 Newton meter per second. So in order to find the work done by impeller on water per second, we know the equation and we should substitute the values to the equation. In order to find the VW2, we should consider the outlet triangle, and tan phi is equal to VF2 by U2 minus VW2. Putting the values, we get the answer to VW2. So now the third question, manometric efficiency. Manometric efficiency is equal to GHM by VW2 U2. Putting the values 9.81 into 50.54 into 25.12. We get the answer as 90.6%. So manometric efficiency is found out by the equation that we already know, that is GHM VW2 into U2. As we already know the values of each component, we put the values and we get the answer. Hope you all understood the problem, and thank you.